Hello everyone and welcome back to our course CSE331. This is our fourth lecture and today we are going to start talking about regular expressions. My name is Ajad Anjum Islam and today I'm going to be your lecturer. Now I know over the past couple of lectures we have been talking about strings and languages over and over again for seemingly as long as we can remember, but fortunately today our topic is going to be all about even more languages and more strings. So let's start. I know we have seen this diagram before, I believe in the second lecture. So we know there are 4 different types of automata, each one more powerful than the one beneath it. And now we also know that each automaton has its own language. So these 4 types of automata has 4 different types of language that they accept. At first, at the very bottom, we have regular languages. And then we have context-free languages and context-sensitive languages that are accepted by push-down automata and linear-bound automata respectively. Finally, we have what's called a recursively enumerable language or the unrestricted language that is accepted by the Turing machine. In this course, in the future, we are going to talk about context-free languages, but for now, our focus is going to be solely on regular languages. So let's come to the problem at hand. Let's say you have a regular language. Now I know we don't yet know what a regular language actually is, but for now, just assume that this is a simple language with a bunch of strings in it. Now one of your friends come to you and he wants to know about your language. How are you going to describe the strings that are in your language to someone else? Well, there are a few things you can do here. Obviously, you can start listing all the strings that are in the language. Also, you can start describing the language in words. Something like
all the strings has a in the beginning or a C in the beginning and some B's in the middle.
Stuff like that. Or this is interesting, now that we know every regular language has some finite machine somewhere that accepts it, you can draw that machine and that will tell you a lot about the language, so that is a fairly good way to describe the language. Now obviously, the first approach is the dumbest way you can go about it. Most languages are not even finite, so if you start writing the strings, you will be writing till the end of time. The second one is not bad. For some simple languages, this might actually work, but often the strings in the language will have a lot of variety. And the more complex the language becomes, the longer will be the description. So this is not really convenient. The third approach can be good, can be really good in some cases, especially when you are writing a software and you are writing a code for the computer. It might be the best way to describe a language if you draw the finite state machine and simulate the finite state machine, but in general cases, describing a finite state machine itself is not an easy task. Like you have to draw a lot of states and diagrams, so this is not very convenient either. So what can we do about it? Well, there is a much better way, and today we are going to learn about that. Now, if you remember in one of our lectures, we said that the strings in a language has something in common, a common property. There is a pattern in all the strings of a language. For example, look at the first language here. There is a very obvious pattern. The strings start with a 1, and then what follows is any number of zeros. So if you have a 1 and a lot of zeros trailing it, you have a string of this language. Now the second example here is not as nice, does not have a very obvious pattern, but at least about these strings we can say that every string is made with Roman alphabets. That's still a pattern. Now some patterns are easy and nice, as we have seen here. For example, this language has a very simple pattern. Every string is going to be made with the symbol A. This one is the set of all natural numbers. This one, these are all binary strings, starts with 0. Oh no, sorry, it does not always starts with 0, but every string ends with 0, right? And in this one, every string starts with 1 and also ends with 1. But not all patterns are going to be so easy to find. Some can be really messy. Like in this language, the strings don't really have any particular pattern that's obvious. But if you really look closely, these are all Java identifiers. So there are alphanumeric characters and $sign and underscore, but no string starts with a digit. That's the condition of Java identifiers. We saw that in our last lecture. This one, again, seems like an arbitrary collection of numbers, binary numbers, But these are actually all numbers that are divisible by 5. So we have 0, then 5, 10, 15, 20, 25. This one, again, arbitrary collection of words, but every string here has a substring re. So there will be some pattern. It might be easy to see, it might not be easy to see, but every regular language has some pattern to it. Now this pattern is what we call the expression of the language. And if the language is regular, then this pattern is what we call the regular expression, or in short, regex. And every regular language has one or more regular expressions. Now the problem is we don't even know what regular languages are, right? And that's a good question, because the actual definition is given the other way. If a language has a regular expression, then the language is called regular. And now the problem is we don't even know what regular expressions are. There is a very nice definition to it, and we will see the definition sometime in the future, but for now, before that, we need to learn a few things. In a regular expression, whatever that is, we will see mainly three types of operators. We have the OR operator, which is described by the straight bar or the plus sign. Now don't be confused with the plus sign of the positive closure. In the positive closure, the plus sign is a superscript, so it stays at the top of the symbol. This plus sign, the OR operator, sits between two symbols or two strings, and this is not a superscript. Secondly, we have the concatenation operator, which is described by the dot. We have already seen concatenation, so this is nothing new to us. Sometimes the dot might not be present, the two symbols or the two strings will just sit side by side, and that still means concatenation. The third operator we are going to see is the closure operators. We will see the lin closure, we might also see the positive closure. We have already talked about these operators in our previous lecture, so this should not be very hard to grasp. We might see some other operators as well, but those are mainly derivatives of these three basic operators, or in other words, you might say those are shortcuts, and we will talk about them later. But for now, these three are the only basic operators that are present in a regular expression. Now let's talk about the OR operator. The OR operator is a binary operator, so it sits between two things, and it means you might take the one from the left or the one from the right. So R1 or R2. So if we take the one from the left, we get R1. We might also take the one from the right and we'll get R2. Some examples here. A or B will give us two strings. If we take the one from the left, we get A. If we take the one from the right, we get B. Similarly, in the second example, if we take the one from the left, we get the string AA, or if we take the one from the right, we get the string B. In the third example, we might get hello or we might get hi, depending on which one we choose. This binary operator can be extended and will work with three or more operands. In this example, 0 or 01 or 001 gives us three strings. We might take 0, or we might take 01, or we might take 001. So now let's move on to the second operator here. We have the concatenation operator, which is another binary operator, so it also sits between two things, and what it means is we will take R1 and we will take R2. So this operator is also sometimes called the AND operator. Now this little expression here gives us R1, R2 both. Some examples will help you understand. If we take A.B, we get the string AB. We get one string which has A and B both in it. If we take AA.B, we get again one string which is AAB. In the third example, we get the string hello hi. Again, this binary operator can be extended to work with three or more operands. In this example, these three operators all concatenated together gives us the string 001, 001. Now let's see some of the combinations here. So in the first example, we have A or B, which is concatenated with C. So if we take A, we get AC. If we take B, we get BC. In this example, we have A or AA concatenated with B or C. So if we take A from here and B from here, we get AB. If we take A from here, C from here, we get AC. If we take AA from here and B from here, we get AAB. If we take AA from here and C from here, we get AAC. Similarly, if we have this, so all four things are being concatenated. On the third string, we can take either OH or NO. So that will give us two strings. If we take OH, we get this string. If we take NO, we get this string. Concatenation has a higher precedence than OR. So if there are no brackets or parentheses, concatenation will come first. In this example, we have A.B or C. We are not going to take the OR between B or C first. we are going to concatenate a dot b first, then we are going to take the or. Similarly, in this example we have hello or hi or oh dot no or bye. So we are not going to take these three and concatenate with these two. We are going to concatenate first and then we'll take the or between these four. So that gives us 4 strings. Now let's look at the closure operators. The closure operator is a unary operator, so it only works with one operand. And what this means is I'm going to take 0 or more occurrences of R1. So I'm going to take R1 0 times, 1 times, 2 times, 3 times, or infinite times. So it will be something like this. I'm going to take R1 and R1 and R1, and I'll keep taking it for as long as I want. And I can take 0 R1, which will give me the empty string. Some examples will further clarify this. So if I take A star, I might take A 0 times. That gives us this little string here, the empty string. If I take A 1 times, I get this one. If I take A 2 times, I get this, and so on. The operators doesn't only work on a symbol. So if I take the len closure on a string, I might take the entire thing 0 times, which gives us epsilon again. I might take it 1 time, which gives me hello. If I take it 2 times, I get hello hello, and so on. Positive closure is basically the same thing. It is denoted with a plus, and instead of taking 0 or more occurrences, I will take 1 or more. We have already seen this concept in our last lecture, so this will go something like this. 0 star will have 1 0 or 2 0 or 3 zeros or 4 zeros, so on. The only difference is we don't have epsilon here. No epsilon, because I will have to take at least one occurrence of the whatever it is that it's sitting on. Epsilon might occur in a positive closure if the symbol itself is epsilon. So if I take epsilon 1 time, I'll still get epsilon. If I take the empty string 30,000 times, I'll still get the epsilon. So the epsilon might occur in a positive closure only when the actual expression or actual symbol is epsilon itself. Anyway, so let's see a few examples combining everything. Len closure or positive closure has even a higher precedence over concatenation, which means we have to do the closures first and then concatenation and then OR. In this example here, we have A or B star and concatenate the whole thing with C. So I cannot take A or B whole star. The B star has to be calculated separately. So if I take A from here and concatenate with C, I get SC. And if I take the right side of the OR operator, and if I take the right side of the OR operator, I can take 0 occurrences of B, which gives me just C. If I take 1B and concatenate with C, I get BC. If I take 2, I will get BBC. If I take 3, I will get BBBC, and so on. In this example, I have AB or XY star. So if I take AB, I will just get AB. If I take XY star, I might take 0 occurrences of XY, which will give me just the epsilon. If I take 1, I'll get just XY. If I take 2 of these, I'll get XY, XY, and so on. This example is 0 or 1 whole star. I'm taking repetition of the string 0, 1 itself. If I take 0 repetition, I will get epsilon. If I take 1 repetition, I'll get 0, 1. If I take 2 repetition, I'll get 0, 1, 2 times, and so on. This is pretty straightforward, really. This one here, it says 0 star or 1 star. So I have to choose between 0 star or 1 star. Let's say I choose 0 star. 0 star gives me epsilon 0, 0, 0, 0, 0, 0, and all the strings that you can make with 0. If I choose 1 star, I'll get epsilon again, but we already have that here. 1 occurrence of 1, 2 occurrences of 1, 3 occurrences of 1, and so on. So all of these strings will be in the set of this expression, because this expression can match with all of these. Well, this example here, I'm taking 0 or more occurrences of the string A or B. So I'm taking A or B and A or B and A or B again, and so on, as many times as I want. This actually means that every position of the string will come from either A or B, which is the same as creating any string of any length using the symbols A and B, right? So if I take 0 occurrences of this, I'll get the string epsilon. For any other number, I'll get all the other strings made with A and B. So if I take these 4 times, I'll get all the strings of length 4 that you can construct with A or B, because the first position can be A, can be B. The second position can also be A and B both. And similarly, the third and fourth position can be either A or B or whatever you want. Not whatever you want, just A or B. Anyway, so for now we are done with the examples here. If this feels new to you, don't worry. You are only feeling that because this is new to you. in the next lectures, I hope we are going to talk about more regular expressions and things will start to clear up even more. Now, if we speak informally, we have a draft definition of regular expressions. Any expression that you can create using these three operators are called regular expressions. This is not the formal definition, we'll see that later. Now there's one last thing we have to talk about today. What are the conditions for an expression to be considered the regular expression of a regular language? There are two conditions. First of all, any string that matches with the expression has to be a member of the language. So if I have a string that matches with the expression, this string must be a member of the language. And the second condition is, every single string that is in the language must match with the expression as well. So if I have any string that is a member of the regular language, has to pass through the test of the expression too. So what does it tell us? Well, if there is a string that matches with the expression but lies outside the boundary of the language, then this expression cannot be the regular expression of this language. Similarly, if there is a member of L somewhere that does not pass the test of this expression cannot be the expression of this language either. So these are the two conditions that must be maintained for an expression to be considered as a regular expression for a specific language. Anyway, so that's it for today. For now, we are going to talk about regular expressions in our coming lectures as well. Until then, take care and goodbye.